Okay, all right. So here's what we're gonna do today. We're gonna continue with the histogram, but we're actually looking at another aspect of the histogram, which is not the graph itself, but the table that you can use to construct the graph. Okay, it's called a two-way frequency table. Okay, so let's take a look and see what that looks like. Okay, all right,
Right,
so
let's
let's go.
see what we're talking about today. Okay, so today we're going to talk about frequency tables and histograms. And, we're really not talking about histograms anymore. That was yesterday, right? So here today we're going to talk about frequency tables, which is really just, it's an evolution of this table, right? Remember all the stuff that we did into this table, okay? It went from a good old frequency table to a two-way frequency table. Now let's see what that even means, right? So for the past day or two, when we talk about frequency tables, it really only tells us like one piece of information, really, right? Because it tells us by breaking down things into different bins, right, called intervals, and then by putting, how do I say, by putting a number into these bins, right, into these various bins by using a tally and then a frequency, it just tells you that how many numbers fall between 1 and 5. So in this case, 6, right? 6 numbers fall. By the way, I don't even know what those numbers are. You realize that, right? Like I'm looking at this table, I can't tell what the numbers are inside the interval, which is one of the downsides of a frequency table. Whereas if you create a, what are those called? Dot plots? Remember those plots where you'll have to like make crosses and whatnot, right? Like these are much more specific because it tells you which number is in there and how many times. This one doesn't really do that. It doesn't really tells you which exact numbers are in there. Okay, but nonetheless, it serves its own purpose, right? And then for frequency of 7, right, which means for the set of numbers, which I don't know what those are, right? For a set of numbers, 7 of those set of numbers fall into between 6 and 10, and then so on and so forth, right? Whereas a two-way frequency table tells you two things, all right? And you can see, right, the word bivariate data, right? Two things. What do they show you, right? The rows indicating one category. By the way, these are rows, right? And these are your columns. So what is that saying? Well, you can break things up into various categories, okay? And as a result, much more useful. So one is, for example, you can break things down by sports, right? So football, basketball, baseball, so those are their own bins, so to speak. And then you could break it down by males or females, so that's its own bin, right? So to read that, right, you can read it two ways, right? Think about that. How many total football fans are there? Let me use different colors for this, okay? What should I do? I should use crayon color, right? So maybe not, I don't know. All right, so for football, you have 40 fans who are female, 12 fans, no, 40 fans who are male, 12 fans who are female, for a total of 52 for basketball, right? And then for baseball. Now, you can also look across, right? So for males, this is how many fans there are out there to begin with, right? 40 plus 22 plus 15. And then you could do the same for females, right? You can have 12, 16, and 45. And then that will give you the total number of male fans. In this case, let me use a different marker. Okay, I like all these different colors really confuse me, right? So this is, let's see, what is that? 40, so 62, 62, 77, right? And then for female fans, that's 16, so that's 28 plus 45. 28 plus 45, that's 73. Okay, all right. 28, 45, all right. Yeah, all right, right? So on and so forth. So it gives you the total for football, basketball, baseball, but it also gives you the total for males and females who are watching the sport. Okay, so that way it gives you a lot more information. Okay, so what we're gonna do is this in this video. We're gonna do one really big problem. Afterwards, we'll stop and then we'll just watch the no, we'll just practice in class. That's what we're gonna do. Okay, so now all of these answers, all of these are highlighted because that's what they're giving you, and then we have to fill out the blanks. Okay, and I could do that by erasing it. All right, see what a genius I am. All right, let's read the question. So let's see. The Senior Spirit Committee sold hot dogs, pizza, water, and soda at a soccer game to raise money. 400 sales were made. 400, right here. 400, okay? They sold 200 sodas down here. 150 bottles of water here. 158 hot dogs. Where are the hot dogs? Oh, right here. 182 pizzas, okay? By the way, one of the things I want to emphasize is it's more about knowing how to read a table than constructing a table from scratch. Okay, even if they were to ask you to construct a table, some of these numbers are filled in already. All right, I just want to say, all right, 50 students who bought hot dogs also bought soda. So you see why the 50s here, right? Hot dog and soda, right? Where they intersect, right? There's 50 of them, right? So you see why these tables are super useful. Okay, 58 who bought pizza also bought water, so that's here, 58 pizza and water. 30 students bought soda but no food. That explains this 30 here. 46 bought hot dogs but no drink. All right, 46 hot dogs but no drink. Okay, so as you can see, the third row here is no food. Third column here is no drink. Okay, organize this table. Okay, so they just want you to fill in the blanks. Okay, so let's do that. Now, let's see. Okay, right off the bat, right? By the way, you can go across or go down. Okay, by the way, this reminds me of that time in 6th grade when we did this. Remember the organizing strategies? Remember the game that we did in class, right? Everyone hold up their thumb, everyone hold up their index fingers, right? And then I ask you, right? So one of the problem-solving strategies was organized data. Remember that? I think I gave you guys a quiz on that too. Okay, anyways. So, so for someone who got a hot dog with a soda, no drink, right? So the total number of people who had hot dogs were 158, right? So 50 of them had soda, 46 of them had no drink. How many of them had water with a hot dog? How would you find out? Yeah, right? You just take 158 and you subtract 50 and 46. That'll give you 62, right? Okay, so far so good. Now, I could go down here also, because one of the things that you realize, if you try to do the same strategy looking across with pizza, I don't have the information for soda and I don't have the information for no drink. So you can't reach any definitive conclusion here as to how many people had pizza with soda and pizza with no drinks. Okay, so that's not going to work. So what do? I just go across and see which one is just missing one value, right? So whereas this one was missing a value, and I could find out, here I'm missing one value, right? So I have 50, 30, that's 80, subtract that from 200, that's, right? That's 120, right? See how easy this is? Now, if I go across this way, right, I got 120, 58, and then no drinks, right? So pizza, soda is 120, pizza, water is 58. What's pizza, no drink? How do you find out? Yeah, you subtract these two from 182. So we get 4. Okay, yep, that makes sense. All right, I always have to have a Coca-Cola when I have pizza. That's the only thing I'll drink when I have pizza. All right, so now what else do I need to know right now? Oh, this one, right? Water, right? Water with hot dog, 62. Pizza with water, 58. Water with no food, right? How many? Yeah, subtract it from 150, right? You see, so far so good, right? Now, no food. Let's see, hold on. What else do I have to figure out? I got these 3 empty boxes, right? Oh, total's 400, so Total is 200 soda, 150 water. How many people did not have any drinks? Yeah, subtract 200 and 150 from 400. Right, so that's 50, right? Makes sense. You see how we're doing this? Okay, you can't solve everything at once, guys. That's one of the things I want to emphasize to you. 46, oh, this is 0 then, right? No drink, 46, 4, no food, so no food, no drink. Nobody. All right. And then lastly, we got 30, 30, 0. What's the total of people that didn't have any food? 60. See? Nothing crazy, right? Very, very doable. All right, let's see. How's the time? Yeah, it's about time. Okay. All right. So again, I want to emphasize this, okay? This goes out to you. All right, spiel time with O Manning. All right. So spiel time. So one of the things I want to get through to you when you solve math problems, you know, and I would have told you this if you were in 7th grade, was that sometimes there's so many blanks in the question that you cannot hope to solve everything in one go. The best you can do is always ask yourself, right? Self, where can I start? Pick one place to start, okay? That's all you have to do. Because once you find one part, all the dominoes are going to start falling into place. That's what you should do. Always ask yourself, hey, where can I start? You can't solve everything at once, okay? Just you got to let go of that idea, okay? So the more you think of it that way, I think the more you'll enjoy solving problems in math, okay? Now, having said that, calculate the percent of sales in each cell for your two-way. Okay, so meaning this, right? Hold on, I gotta double check something. Okay, all right, I have to double check something. Now, the question here is this, okay? Pause to take a look at this. Now, notice how I actually just wiped everything out, right? So the question is this, all right? Listen carefully. For the number of people who had hot dog and soda, which is 50, by the way, it's right there. How much percent of this is the total? How many percent of this is the total, right? Think percentage, right? So what's 50 out of 400? I can ask Google right now. All right, and I'll let Google give you the answer. You should be using a calculator, by the way, not just straight Googling. Okay. Hey Google. Hey Google. What's 50 divided by 400?
The answer is 12.5.
Okay, I don't know if you can hear that. All right, so 12.5%, right? So on and so forth. So 120 over 400, okay? All right. I'm gonna move my Google Doc into my study. All right. Hey Google, what is 120 divided by 400?
According to Wikipedia, 120, read as 120, the natural number following 119 and preceding 121.
Okay, that makes no sense.
In Germanic languages, the number...
Okay. Oh my God, she can't answer my question. All right. So it's 30%. All right. Is that right? Hold on. Let me double check. Wait. Let's see. 120 divided by 4. Yeah, it's 30%. Right. Okay. All right. All right. So on and so forth. So you do 30 over 400. If you want, actually, you know what? Why don't you press pause right now and go ahead and do these real quick. Okay. So press pause right now. Okay, all right, and we're back. So I'm just gonna show you the answer real quick because we have to come back to class. That's it. Okay, done. All right. That's that. Okay. So thanks for watching. Come back to class, and then we'll practice a lot. Okay. All right. See ya.
OMG, that was so good.